All right, we're going to start this chapter in this section. We've already started the chapter. We're going to start this section by talking about interval notation. Just some review, probably review for most of you, on different ways of expressing intervals. So how we're going to begin this is we're just going to make this giant table, okay? And in this table is going to have a row of inequalities. A column of inequalities, a column of how you write that in interval notation, a column for graphing something on a number line, and finally, something that we're going to call set builder notation. So, just going to do this and go all the way down to the bottom on all of these and introduce officially interval notation and set builder notation. All right, so if we have an inequality, something like x is bigger than some number a, kind of looks like a 7, x is bigger than some number a, on the number line, and let's say a is right here, we can use a parenthesis and then shade everything to the right of that parenthesis. Bigger is to the right on a number line. You may also sometimes see an open circle. For the number line, we're going to use parentheses here. But open circle and parentheses are the same thing. I'm okay with both. So interval notation kind of just takes this and makes it look a little quicker, a little neater, a little cleaner, shorter, smaller. All right, so we still have a parenthesis. The parenthesis is at a, and then it goes all the way to infinity. Infinity also gets a parenthesis. Okay, the smallest number is always on the left. The biggest number is always on the right. For something called set builder notation, we put it in set brackets, these braces, and we're going to say that this is the set of all x such that x is bigger than a. And so that's kind of how this is said. The set of all x, and then this vertical bar means such that x is bigger than a. All right, but in reality, all that's ever changing is this. The set builder notation will make a little bit more sense the more we use it, I think. Let's do another one. So if we change this to x is greater than or equal to a, it's pretty similar, right? On the number line, it's almost going to be the same thing. The difference now is that we use a bracket or a closed circle. Again, sometimes you might see it like this. Well, interval notation is almost going to be the same. The only thing that changes is the only thing that changed on the number line. So instead of parentheses a, it's going to be bracket a. And this is going to look a little weird because it's still a parentheses on the infinity, right? Infinity and negative infinity always have a parenthesis, okay? I thought I just heard my cat whining. Hope she's okay. Hope she's somewhere nearby. Anyway, so watch out for that. And then we can kind of combine things as well. Like if we could go the other direction. X is less than some number. Then on the number line, right, here's a. We have everything to the left. It's not included, so it's a parenthesis, like so. And again, the smallest number is always on the left. Smallest number is always on the left. So here, what's the smallest number? The smallest number is negative infinity. What's the biggest number? The biggest number is a. The biggest number is not included, so it gets a parenthesis. Negative infinity always gets a parenthesis, and so on. Oh, I skipped my set builder notation. This is the set of all x such that x is bigger than or equal to a. So it's almost the same, right? Every time it's going to be very, very similar. This next one, the set of all x such that x is less than a. Okay, so you're seeing the pattern, right? It's almost the same thing every time, just a little different. It's what goes in here that changes. All right, we can combine these two things a little bit. Let's do one more. We could have a compound inequality. A is less than or equal to x, which is less than b. Then on the number line, right, now we're talking about between a and b. It includes a, so that gets a bracket. It does not include b, so that gets a parenthesis. All right, my cat is here. She is okay. If anyone was worrying, I was worrying. And then we reflect this right here with the interval notation. Smallest number it can be is a. Biggest number it can be is b. B is not included, has a parenthesis. A is included, it gets a bracket. And then over here, we just kind of copy down this inequality for the set builder notation. The set of all x such that x is less than or equal to a, or x is bigger than or equal to a, and less than b. Okay? I have this, this excellent trick. You might say, Jason, I can't see behind you at all. Don't worry, I have a fix for that. And the fix is ghost Jason. Okay? Everything, no more problems. It's all working according to plan. Spooky. All right. So that's what we have right here. And the last one I kind of want to mention real quickly is what happens if we have all the points except for a. So on the number line, the parentheses are kind of hard to use here, but the open circle really shines, right? We just have an open circle at a, and then we go in both directions. But I'm going to try to be consistent and show you what happens if we use a parenthesis. It's everything bigger than a and everything smaller than a. And that's exactly how we have to write it in interval notation. It's everything bigger than a, that's a to infinity, and everything smaller than a, that's a to negative infinity. And then we're combining both of these sets together. We combine them with this big kind of parabola. It kind of looks like a giant U. This is called the union sign. And that's how we write it in interval notation. There's two intervals, right? Bigger than a, smaller than a. It's another way of saying just everything that's not equal to a. And that's how we write it in interval notation. Set builder notation here is pretty easy. That's just going to be, I need to turn off the autosave. It kind of messes up the pen. Set of all x such that x is not equal to a. There we go. That's interval notation. We'll do one example to show kind of what can happen with these. But that's the big introduction on different ways of writing different kinds of intervals. Let's do example 1 here. Write the following. In set builder and interval notation. We'll do a couple examples. Our A is going to be x is less than 3. And when in doubt, a number line can always help out. All right. So if we wanted to write this on the number line, right, it's all the points that are less than 3. The 3 is not included. We'll use a parenthesis or an open circle. This is what it looks like. So in interval notation, what's the smallest we can be? Negative infinity. Infinity always has a parenthesis. What's the biggest we can be? 3. 3 is not included, so we use parentheses. That's what it is in interval notation. Set builder notation is always the set of all x such that blank. Every set builder notation for domain is going to look like this. Range, we usually replace it with a y, just because y is usually for y values, outputs, range outputs. So this is going to be the set of all x such that x is less than 3. And that's part A. Part B, let's do -2 less than or equal to x less than or equal to +5. X is between -2 and +5. Now, these are both less than or equal signs. So we write it like this, and this is what it looks like on the number line. And again, be very careful with this piece right here. This says -2 is less than or equal to x. But you could also think about that as x, right? X is bigger than or equal to -2. These pieces are equivalent, right? If I'm shorter than you, you are taller than me, is the kind of idea that's going on here. So we're just going to write -2 to 5 like this, and the set of all x such that x is between -2 and +5, like so. We can do one more kind of weird one. X is not equal to 2 or 3. On the number line, let's pretend that's a line, shall we? This is everything except 2 and 3. So it's everything that's less than 2, everything that's bigger than 2 until we get to 3, and then everything that's bigger than 3. So it's almost everything, right? Almost the whole number line is shaded blue, but not 2 and not 3. So we have 3 pieces this time. Everything less than 2, everything between 2 and 3, and everything bigger than 3. And we just connect them all with the union sign. All right, let me know if you have any questions. That's interval notation.